Okay, so this is the last video in the sequence of lessons for Chapter 2, the Conditional Probability chapter in your Year 2 Applied Maths whilst you're working at home. And this is kind of the meaty stuff. This is the kind of questions you're going to tend to get on exams. Can sometimes be quite tricky if you get lost in the context of the question. So I've got a couple of examples to help you through that. We're going to focus on using the conditional probability formulae that we learned in the previous lesson, mostly using the conditional probability equation, the fact that probability of B given A is equal to, hopefully you know this now, it is A intersect B over probability of A. And remember we said what's the probability of both of these happening over the probability of what's given. Okay, so both over given. We already know that if we're looking at tree diagrams, then we don't really need to worry about working with the formula, but sometimes we do. Sometimes, even if it's a tree diagram question, we can't just times the two branches together to get our intersect. If we're working out a given, then we might have some more maths to do. So I've got a bag containing six green beads and 4 yellow beads. Not replaced, two beads taken. So we need to draw a Venn diagram, a tree diagram for that. I'll give you a second or two to pause the video and have a go at that for me. Okay, so the tree diagram I've not drawn in ahead, so I'll do that now. So our counters were green and yellow, so let's go probability that G1, probability of yellow 1, probability of green 2 given green 1, probability of yellow 2 given green 1. This will be green 2 given yellow 1, and this will be yellow 2 given yellow 1. It was 6 and 4, so we've got 6/10, 4/10. Notice I've not cancelled these down. If I cancel these down, I might mess up these values, whereas now if I'm looking at here, I can just take one off the top and the bottom. This will be 4/9. This is going to be 6/9 and 3/9. You can go back and cancel these fractions down if you want now. Yeah, we may as well do that. 3/5 and 2/5 and 2/3 and 1/3. Okay, so if we go back to the question now, it says, given that both balls are the same colour, find the probability that they are both yellow. So we are looking for probability that they are both yellow given they were definitely both the same colour. Okay, so if we apply our formula to that, that will be, we will need to work out the probability that they are both yellow and both the same colour. I'm going to do a plus. Which, if you think about that, that's only going to happen if they're both yellow, over the probability that they are both the same colour, because that's what we were given. So, both same colour and both yellow. The only way that can happen is if they're both yellow. So we want yellow for 1 and yellow for 2. That's here, that's 2/5 times 1/3. And we are going to divide by the probability that they are both the same colour. They can be both the same colour by either being both yellow or both green. So both yellow or, so and, both green. And that's 3/5 times 5/9. Okay, so that's the equation that we need to use. If I work that out, that's going to be 2/15 divided by 2/15 plus 15/45. I'll just grab my calculator and work that out. So that comes out at 2/7. Okay, so if we just reiterate what we did here, it was probability of the both being yellow, given that they were the same colour. It's on the top is both of these things happening, so both yellow and both the same colour, divided by what was given, divided by the probability that they are both the same colour. Because this is quite a hard topic, I've taken the first question from exercise 2E and I'm going to work through that as well. You might want to stop and have a go at that yourself first. And then look at how I did it, or if you get stuck, carry on with watching the video. Sorry, dog was trying to make an appearance. She's gone. Right, so we've got 5 red counters and 5 red tokens and 4 blue tokens. We're going to draw the tree diagram for that. So we've got red 1, blue 1, red 2, given red 1, blue 2, given red 1, red 2, given blue 1, and blue 2, given blue 1. It was 5 and 4, so 5/9, 4/9, and we've then got 3/9 and 3/8. Wait, no. What am I doing? Get rid of that. That will be 4/8 and 4/8, and down here we are going to have 5/8 and 3/8. Okay, so that's our tree diagram. I've actually changed some of the questions slightly to help us with kind of thinking through the questions. So question part 1, or B part 1, I've asked for, and I'm not sure if the textbooks asked for this or not, the probability that the second token is red. So we want the second token to be red. The second token is red here or here. So the second token is red will come from either having red then red or blue then red. So that's how that can happen. So it's going to either be red 1 and red 2 or blue 1 and red 2. That's how we can end up with a second red token. red 1 and red 2 will happen by having red 1 and then red 2 given red 1. So that's 5/9 times 4/8. Or it's going to be blue 1 times red 2 given blue 1. And that's going to be 4/9 times 5/8, which is going to be 20 out of 72, add 20 out of 72, so that's 40 out of 72, 20 out of 36, 10 out of 18, 5 out of 9. Part 2 now says, what's the probability that the second token is red given that the first token is blue? So we want probability of red 2 given blue 1. So we can use our probability formula now and say that's going to be both of these things happening. So red 2 and blue 1 divided by the given, divided by the probability that the first one is blue. Okay, so probability of having red 2 and blue 1. Well, that's this. That's blue 1 times red 2 given blue 1. So that's going to be 4/9 times... Oh, in fact, we don't need to do this. It's right there in the question. It's this. Red 2 given blue 1 is 5/8. That's it. Part C, again, I don't know if this is in the textbook or not. It says the first token is red given that the second token is blue. Okay. We can't get that from the diagram straight away. So probability that the first token is red given that the second token is blue. That's going to be the probability that the first token is red. Whoops. And the second token is blue over the probability that the second token is blue. So probability that the first token is red and the second token is blue is going to be red 1 and blue 2 is going to be this. So 5/9 times 4/8. Divided by the probability that the second token is blue. So that can happen in two ways. We can have red 1 first and then blue 2, or we can have blue 1 and blue 2. So that's going to be 5/9 times 4/8. That's the highlighted way, but we need to add on here the probability that they were both blue. So add on 4/9 times 3/8. So that's 20 over 72 divided by 32 over 72, which is 20 over 32, or 10 over 16, which is 5 over 8. And then for the last part, I have got the probability that the first token is blue given that the tokens are different colours. So probability that blue 1 given different colours. And again, if we use the formula, that's what we need them to be. We need the first one to be blue and them to be different colours. Divided by the probability that they're different colours. So If we look at the top, how can we get the first one to be blue and them to be different colours? Well, that's just going to be blue 1 and red 2. So that's blue 1 and red 2. That's going to be the numerator. Divided by any way that they can be different colours. So we can have different colours by having blue 1 and red 2. Or we can also get different colours by having red 1 and blue 2. So that's 5/9 times 4/8, which is going to be 20 out of 72 divided by 40 out of 72, which is a half. Okay, so hopefully that's helped you if you started exercise 2E and got stuck, but if you haven't, then it is now time to have a look at exercise 2E. As I've said a million times already, if you've got any problems, any questions, leave a comment and I'll try and answer them. If you want more examples, let me know that and I'll work through some more questions. Just let me know. Okay.